in series. So if I see those words later on, I'll know what's involved there. So guys, the word series indicates summations. You've got sequences going on. Shane, do you recall where we stopped?
Yep.
I know we were doing sequences.
We finished with the K equals 1 base up to 100.
Up to 100, we were talking about that, and you had not, I did not show the formulas yet. On the back where there was this list of formulas, I think.
Yeah, we're just about it.
Just about, thank you. Okay, let's do this, guys, before I jump into all this. She's telling me that I think I looked at
The one that Gauss did.
Mr. Gauss, mathematician. We started with what, 1 through 100? Okay. You guys will have to realize how to read these. So it says start at the base, replace K by the base number, which is 1, and then build up to 100. Well, that looks like this, 1 plus 2, and I expand this out. And you're going to stop at 100. And I think at the conclusion we were asked how much will those numbers all add up to, sum up to, and Mr. Gauss, the mathematician, I think I showed you what he did to get the answer. Does anyone recall what the answer was?
5,050.
5,050. Okay, and then I did show you how Gauss approached it, by adding twice. Now that said though, let's do this. If you and I are asked to do this, maybe from 1 through 49, and it means this, when I expand it out, it wants to sum all the way through 49. We could try to apply what Gauss did and get the answer. It may be a little time consuming. Guys, just for a little reminder before I jump into some formulas, does anyone recall what Gauss did, let's say for an example, to get the answer for this one? He says the sum is, and when you use S for sum, he's saying, well, you're looking for this, for a sum. No problem. But should I get the same sum if I add backwards? That's what he was doing. So like start out with 49, plus 48, plus 47, and down to and end with 1. He was sort of adding backwards. And then he noticed as he lined these up, who on earth would think about doing this, but he did. I think all those pairs add up to, in my case, what, 50? Mm-hmm. And so I have now two sums, two S's, the way we're doing this. And I have 50, a 50, a 50, a 50. In fact, I have what, 49 of those? Mm-hmm. So I got 49 of those sums of 50s. Divide by 2 to find the sum. And this is sort of what he did. So we end up with the sum to be equal to, guys. So merely it comes down to what? 25 times 49. Whatever that is. But that's an approach I could take. Is that true? Now what is 25 times 49? Does anyone know what it is? 1225? Mr. Hahn says it's 1225. Now guys, I love what he's doing here, Mr. Gauss. I love what we did to get the answer. It's a little lengthy, but it can be done. Now, Shane, before I go back to you, if, by the time you reach a Math 7, a calc course, let's try this again. You're not going to have the time to do this. You realize it can be done, but you're not going to have the time to set this up nicely like he did, Gauss, and get the answer. They want you to find the answer a little bit quicker. Now, I'm going to just go ahead and give the formula to you. There's a series of formulas coming up. Shane, remind the class, was there a formula for, before I jump into this, let me use a different color here, for, just in case I need it, a summation, when you're asked to add I always start with a 1 through n of k. Was there a standard formula I could use to get the answer rather than doing this?
Yes.
Because I think I gave you a set of formulas on the back there somewhere. I hope.
Yeah.
And what was that
If it's
particular?
AK? Oh, no.
No, not that one. It's a summation.
Fourth? Oh, but that's K equals, yeah,
And what did the formula say?
N
N
times N plus one over two.
over 2. So guys, if I use this, and I'll accept it as a formula, n times n plus 1 over 2. If you look back at what Mr. Gauss did, right there it is. N 49 times n plus 1, add 150. This is n plus 1 divided by 2. Same thing. But now written in a formula for us. Therefore, I could find the sum up here by using directly the formula, rather than going through this. So guys, if I did apply the formula, then I'll see what Shane has there for us. Guys, would it look like this? 49 is n. N plus 1, of course, is 50. All over 2. And we're right back to where Gauss was. Which you guys told me came out to be, Mr. Hahn says what, 1225? Mr. Hahn?
Yes.
Yeah. And that's one of the formulas. One of the summation formulas that we need. Shane, what was that question?
No, I actually answered it myself.
Okay. Now, Shane, you've helped me out so much. I think there are a few more formulas now. Maybe you need to move to the top one there. What was the very first formula?
Could you remind me the name of the Greek letter?
A summation, sigma.
Sigma? Okay.
Yeah.
So, sigma base K equals one,
Always wanted to start with 1.
top N,
N.
CA base K.
Okay, tell me again. A.
CA,
Oh, C.
C times A, subscript K.
Like that.
Yeah, and then subscript K on the end.
Got you. And they used a subscript K there.
Mhm.
And what did the formula tell me I'm allowed to do if I see something like that?
Remove the C.
I can move the C out front and rewrite this as C, the coefficient out front, then my summation from 1 through n, and left is this expression they used in the textbook, A subscript K. I'll show you what that means here, guys, shortly. There's another formula. In fact, I could show it right now. Before I jump into all this, suppose you're asked to sum up, add up. Let's try one here, maybe out to 5. And inside here, let's say it was a constant 6K. Do something like that. What am I allowed to do if I wish? I can move the 6 out front, which sometimes will help, almost like a distributive property. Leaves K, and K from 1 through 5. And of course, guys, you can quickly find out what that is there, and multiply it by 6, and get an answer. Just applying formulas. Shane, please help me out. What else do we have for formulas?
We've got sigma subscript K equals one.
Okay, K is equal to 1.
Up high is N. And then in parentheses, we have A subscript K plus B subscript K.
Now. And the formula says, if I need it, what am I allowed to use now?
You're allowed to use sigma base K equals 1.
1 through
N.
n of,
A subscript K plus sigma.
sigma again.
Starting at 1 up to N. B subscript K.
Thank you. In other words, guys, you can split that up. And I'm going to apply all these formulas for you shortly. You are allowed to just split them up into 2 sigmas. Shane, tell me another formula.
Sigma.
Okay?
Starting
I'm
at
going to
K.
bring it up here. Sigma.
Yeah, starting at K equals 1
Okay.
up to N. And it's C.
C. And
is equal to C times N.
now let me stop and show you an example of what's going on with this one. This one, guys, says, if somewhere, and eventually we're going to use it, you're asked to add up, let's say, from 1 through, let's say, 40, and inside here you have a 3. That C represents a constant. You just have a constant, no variable with it. Translated? What does it first look like translated? What do they ask me to do? They just have a constant in there. Or they asked me to take 3 plus 3 plus 3 on until I end with plus 3. How many times? 40. So they're saying if you see that, it makes sense. Just multiply these two together. So you get the grand sum. Multiply n times c or c times n. And guys, in this case, I've merely multiply what? 3 times 40? So the sum should be 120. So that's the summation of a constant, done fairly quickly. Shane, did we have maybe one more?
We do.
Well, thank you. What was it?
Sigma base k equals n up to, or k equals 1 up to n.
Okay.
Sorry. K squared.
Okay, and what's the formula?
N times n plus 1 times 2n plus 1.
Okay,
All over 6.
all over 6. Now that one may be a little bit more difficult to memorize or get to know, but she tells me that's the last one I'm going to be responsible for. Guys, I'm going to try this and see what happens. If, for an example, you're asked to sum up sigma, let's say from 1 through, let me make it fairly short, 4 of k squared. Looks like that. Let's actually expand it out and see what it means. So start with 1 squared, then build it up to 2 squared, 3 squared, and end with 4 squared. And you could easily do this one. This merely says add up 1 plus 4 plus 9 plus what is it, 16? Is that 30, guys? I did it quickly. Is it sum 30? Done. We could easily do that. The problem is, and the reason we have this strange formula, is suppose they had asked me to add up from 1 through 150. You do not want to expand that out. It would take you forever to sum those up. So I need something else to help me, and that's the formula. And she's saying, Professor, if it looks like this, use this formula up here. Guys, let me first apply that formula to the simple one I had here. If I had done this by formula, not expanded and had done it by hand here, my formula says n in my case was, for the simple one, what was it, 4? Yeah. So n is 4. N plus 1's a 5. 2 times 4 plus 1's what, 9? And all that's over 6. That's what the formula says to do. Clean this up the best I can. I'm going to do a little canceling here, guys. 3 goes into 6 twice. 3 goes into 9 3 times. That would help. I could cancel 2 into 4. That would help. So, guys, I got 2 times 5 times 3. Please tell me, is that 30? The way I did it. So with the formula, also give me the same answer a little bit quicker. So now I have all these formulas to make use of if I need them. Your textbook, I think, also gave you a summation for k cubed. I will just stick with k and k squared. Take a close look at it. Formulas are just straightforward. Now, Shane, did I have some examples at the bottom there to close us down?
We did.
Like what?
Okay, we had sigma base k equals 1.
Okay.
Up to 14.
14.
And then in parentheses, k squared minus 7k plus 2.
Oh. By the way, was that the only example I had there? Shane?
Nope.
Oh, got something else?
Yep.
Okay. Guys, let me write just the first couple of terms out and show you how trying this would be to do it by this writing the terms out. If I replace k by 1, help me out guys, that's 1 squared, subtract, I'll get 7 there, plus 2, and I'll come back to it. Let's write the next term out. Let's replace k by 2. That would be 2 squared, subtract 14 plus 2, and this is supposed to go on until you finally end up with replacing k by 14, which will be awkward, but it looks like this. I think 7 times 14, help me out guys, 98, I think, plus 2. That's the way the last term would look if there's no mistake. You guys agree? That would take forever. You just directly go through and add those up. Okay. First couple terms, by the way, the term right here all together, guys, help me out. 1 subtract 7 is what? -6. -6 plus 2 is a -4. The next term looks like 2 squared is 4. 4 subtract 14 is what? -10. -10 plus 2 is a -8. Oh, there's a pattern here. And it goes on. Down to that last one. Is that true? That's what I'm looking for. Now, that's what it looks like expanded out. The entire expression. That's what it looks like expanded out. You guys agree? Now, Shane says, Professor, rather than expand this thing out and taking the time to do it like that, why not apply the formula? In other words, first you're allowed to split this up into from 1 through 14 of k squared. Subtract summation 1 through 14 of 7k plus summation 1 through 14 of my constant 2. And Shane, I think actually I'm applying this formula here.
Yeah.
You're allowed to split them up, which I have. Now, can I deal with them? Well, to deal with the first term, after I split this up, she gave me also, I could use, now this formula. The summation for k squared. And if I do it right quickly with k squared, it says n in this case is 14. n plus 1, 15. Do not let me make a mistake. 2 times 14 plus 1, guys, is that 29? Help me. All together? All over 6? Yes or no? That's the way the first one looks. Don't stop there. Subtract now. Now, can anyone tell me, based on what Shane did for us, how can I rewrite the second term? Summation of 7k. I moved the 7 up front. I saw one of the properties she read for us. Allows me to do that. And that would leave me that. Before I leave that term, can I use another formula she gave me? In other words, this can be done, if I'm careful, with the help of, I think it's more like Mr. Gauss's formula. Where on earth was it? Back here somewhere. This one. I can now apply this formula, which says n times n plus 1 over 2. These formulas are very critical here. So guys, in this case, that's n 14 times 15, n plus 1, all over 2. I gotta keep in mind I have a 7 out front of that. On the end, can I, for a summation of a constant 2, do I have a formula that I can apply there? And I think, is it this one? Can I apply this formula to get the end result? And if I do, it merely says multiply these two together to get the sum right quickly. And guys, that would give me easily on the end then, what, 28? 14 times 2 for the sum. Guys, have we followed the formulas? Now, if I clean this up, it's going to be a mess. Bear with me. I'm going to do the best I can here. Someone's going to help me here. I could do a little canceling here and take 6. Oh, boy. Help me out, guys. Could I reduce this down by 3, maybe into a 2 and a 5? That would help some, wouldn't it? And then I could take the 2 here into 14, get a 7. That would help. So I'm left with still awkward. 7 times 5 times 29. Or 35 times 29. Mr. Hahn, what is that?
I haven't checked that, sorry.
Or Mr. Park, what is that? 35 times 29.
I don't know.
Oh, gee. Give me that gift back.
I think it's 120.
Oh, that's
1235.
That's what I think. What is it?
1015.
How much is it?
1015.
1,015?
1015. Wait,
Mr.
I think I'm wrong then.
Mr. Hahn, you think it's that?
Yes.
Okay. Now, the next one says, do a little canceling here, guys. 2 into 14 is what, 7? Oh, this is awkward as you know what. That's a 7 times 7, 49 times 15? What's 49 times 15?
735.
735 sounds reasonable there. And of course, on the end, we have that already for 28. So guys, whatever that would, grand total would be, 1,015 he gave me, subtract that, plus 28, that would be the answer for this. With the help of the formulas. Do you have a grand sum here?
Let me check.
1,015 subtract 735 plus 28. And I think the call whether I wrote the answer down for this or not. Shane, I did not get the answer to that on the handout, did I?
You did not.
Okay.
I think it's 308.
308.
How much?
300.
308. With the help of the formulas. Okay, guys, so know your formulas. Summation of k, summation of k squared. When can you split them up? A constant being summed up. All those formulas that she read to us. You gotta know how to work with them. Shane, what's left there?
We've got one more.
One more. Let's get that out of the way. What was it?
Sigma base is 1 up to 90,
90?
90.
Okay.
3 minus 2n.
3 subtract 2k.
2n.
Well, it should be a k.
Okay.
Did I have an n down here, by the way?
Nope.
Okay, let's put a k in there, guys.
Okay.
Okay.
And if that's in parentheses.
And that's the last one.
Yep.
Okay, what would you suggest of all the formulas to do first, because I do not want to write these terms out.
Separate
Separate it?
Yeah.
Okay, and rewrite this as summation.
Mhm.
And I'm going from 1 through 90 of 3, subtract summation of 1 through 90 of what, 2k she gave me. I'm allowed to do that by a formula. Now tell me, what would you do next? Thank you. First one's easy. Just multiply these two together. 270. What would you do on the second term?
Move the 2.
Move the 2 out front. That's a property that allows me to do that. As I move that 2 out front, I am left with just k, which I think going back there is the very first formula we had, Mr. Gauss's formula. So guys, I got 270, subtract 2 times, and here it goes. If I apply the formula there, it's 90 n times n plus 1, 90 times 91, all over 2, and see if you guys agree. And just clean this up, and I will have the answer. It's like 270. These 2's cancel. 90 times 91, I'm trying to do it here myself, help me out. 8190? And what's the final answer going to be? Negative. Negative how much?
7920.
7920?
Yes.
He tells me it's that. Okay? Guys, know your formulas for the final exam. Now, can I get really crazy on you? No, because this is the first time you're seeing these formulas. But know your formula. That board is full of formulas. Shane, what was that?
Are there names for the various summation formulas?
No, there's not. This one, let me go back. I identify this as Mr. Gauss's formula. Your textbook does not give a name to these. Okay, so know your formulas just by recognition. Which one should I be using here?
Isn't it linearity?
What's that?
Down to equation linearity.
This one here?
Yes.
Your textbook might. I don't think that your textbook gives a name to it.
Okay.
Guys, anything else before I erase? Lots of formulas? Like I said, know your formulas. Now, before I give you the handout here, that long handout with the conclusion of the course. Let me do my work on this side here. And then we'll get to the other handout here. We'll be done here. Guys, let's call this part 2. I'm gonna try this. Let's see if it'll work for me. I want to try. Find it. Here it is. Summation. I think you guys should see this. I'm gonna start with k is equal to 1. Now, some students have asked in the past, "Said, Professor, does it ever start with 0 at the base?" It does. You have to do a little modification on it. We're not going to modify this, not in this class. So we'll start with 1, okay? Could start with 0 though. And at the top, I want that. Why not? Then inside here, for the expression to work with, I have written like this. Looks like that. Now, if I were a beginning student and I saw that, and said, "Wait, Professor, I followed you sort of on this." Now, notice at the top, Professor, you had an N, which means I stop. And whatever that number is at the top for that N. This one says, don't stop. Add forever. That's what it says, sum forever. I would think as a student, if you're going to sum forever, the answer should be infinity. Right? If you just keep going, add, it's going to sum up to infinity. If you sum forever, is that true? You'll be shocked at what the answer to this is. No, it's not 0. Not that shocking. Okay. But it's something.
Is it approaching a number?
Yeah, thank you. It's approaching a particular number. It's not going to get there, and we finally accept that number as the answer.
Okay.
But what is that number? It's approaching. Let me write a few of the terms out first. Guys, it says start with 1. If I replace k by 1, my first term looks like this. 3/10 times 1/10 raised to 1 subtract 1. That's my first term. Let's write another one out. Replace k by 2. If I replace k by 2 in the expression, it looks like this. Is that true? We'll try one more. Let's replace k by 3. The expression looks like this. Replacing by 3. And we're supposed to go forever. I've written out the first 3 terms. You're going to be shocked. You're going to be shocked. I'll tell you ahead of time, when we look at this a little bit closer, it's going to give you something that the middle school kids across the street have seen many times. They haven't seen it like this, but they've seen what the conclusion here is. Guys, I'm going to simplify this. The first term, 1/10 raised to the 0. Is that 1?
Yes.
And 1 times 3/10, so my first term is merely 3/10. My second term, if I simplify it, this 1/10 raised to the first, 2 minus 1, that's 1/10, times the 3/10 gives me what? 3 over 100. My third term, if I simplify it, this is 1/10 squared, which is what? 1 over 100, times 3/10. Please tell me all together, is that 3 over 1,000?
Yep.
And it goes forever. You say, Professor, I still don't see what number you're asking us to get the answer for. But you're telling me I saw it back in middle school. Does anyone have an idea? Then wait till you see what happens here. No.
Is it approaching 2?
Okay, approaching 2. I might think that also, and it's not. I see why you said that though, Bill. I see exactly why you said that.
1/3.
Oh, now how on earth 1/3? Let's look at this. 3/10 could be expressed as, we all know, in decimal, 0.3. It says add to it 3 over 100. That in decimal, if I'm adding, 0.03. 3 over 1,000 in decimal, 0.003, and it's supposed to go forever. Well, even at this point, if I sum these up, please tell me, do I get this? A string of 3s. Which, since we're supposed to add forever, means it's supposed to go forever, and more than likely, you saw this written as 0.3 was the 3 doing what? Repeating. Now, who recalls from middle school what fraction is equivalent to 0.3 with the 3 repeats? 1/3. Ignacio, who would think, look at this mess up here. All this is equivalent to this. I heard some of my students say 1/3. Now, Ignacio, Mr. Mathematician, is it going to ever get there?
Yep.
No. Because I keep adding, keep adding, keep adding, keep adding, keep adding, it's not going to get there. So they say this converges, and I like to use that word. It converges to 1/3. But we accept 1/3 as the answer, but it converges to 1/3. So I thought I had to show you that. Show you what it was equivalent to. So Shane, you're telling me I'm finished with that handout. Guys, if Ramsey's done it, I hope I have, here it goes. This is the conclusion of your course. If I can get all this done.